right, this will take some time. Why is it so slow, the recording? Okay. Now, so question number 1, Lab B3, okay? Specify the register content and the status register when the following instruction is executed, okay? So let me copy this one and put it here. Okay, so this is the instruction. So first you XOR R0 with R0. Anything you XOR will become 0. So you can step forward. So it become 0. Alright. Then you move R1 to FFF. So you can see R1 become FFFF. We move 66 to R2. 66 become R2. Then you add. So this is X. So that means the flag is modified upon the operation. R1 you add 1. Okay. FFF you add 1. It will affect the flag. So you can see the flag 0 flag is already affected because the result is 0. Carry flag is also affected because FFFF plus 1 is called carry. The carry flag is set. Okay. Then you subtract R0 by 1. R0 is subtract by 1. Okay. The flag, negative flag is set. Okay. So you can see FF minus 1. Then you add R0, R1, and R0. Both of them, you add them together. This is no S, so the no flags will be set. So you add, so it become FFFF. Okay. Both add together become FFFF. Then you subtract with 86, you get 79. Then you OR it, you get 7F. All right. Probably here is difficult to see. Let's go to the Word document. So you subtract R0 with 86. So R0 is FFFF minus 86. You get 79. Then you OR it with R2. Okay. FFFF. And R2 is 006. Okay. R2 is 006. So what you have 66. So you can see when you OR it, FF with OR with 0, you get 0. This one when you OR it, okay, FF, you 00, you get FF. Then the 79, you change it to binary. Okay. So from this binary, you OR it, you get 0, you get 7F lah. 00 is 0, 10 is 1. So you get 7F. Okay. Is that clear? Yeah. Any question? So far, so good. Okay. Okay. Question number 2. Write ARM instruction with the following. You load 30 to R1. So you can see R1. You move R1 with a symbol hash 0x30. Okay. Hash 0x30. So if you want to have a hexadecimal value, you must put the X. Okay, this one, the hash means is immediate. Okay, so then you have 0x, it means hexadecimal. If you don't put, default will be, okay, if you don't put. Okay. Default will be a decimal value. Okay. So you move it, then what happened? You want to subtract. So what you do, you subtract R1 to R2. Okay. Then you want to store it in a memory location. Because this is a rich processor, so you cannot directly store it into the memory. So what happened? You have to specify the memory location. You have to put it in the R3, the memory location. Then only you can store it. Okay? Clear? So this is the code. You can run this code in the simulator and you see the result as expected. You can see whatever the value in R3, it will be stored inside the memory location. Okay, clear. So the word store means that you store the value of R2, register R2, into a memory location specified by R3. Okay, that is the syntax. All right. So let's run the code and see it for yourself. How is it working? Okay. All right. So we cut and paste, copy, and then go to the simulator, reset, delete, and paste. Okay, then you do a step forward, you can see R30, all right? And let's change some code. So we use, let's say R5 R5, you're not using R5, put it immediate value, 22. Okay, so we do a step forward, 30. You can see here 16, all right, because this is a decimal value. Okay, you want hexadecimal value, you have to specify 0x. Okay, then you subtract you want R2. You want to subtract R2 minus R1. So R2 minus R1, you get 0.9. Hey, wait a minute. Wait. You want to subtract 30 minus 39. So it's actually like this. This is wrong. It's actually R1, R1, then here is R2, like this. Then what you do, you store R1 here. Okay. So now you run again. Okay. Now 30 minus 39, you get this one. And you store the memory location. And you can see the memory 07500, you get this value. Okay. Yeah? Any questions so far? Any questions so far? No, Okay, question number 3. Write the instruction to clear R0. So clear R0, basically, you can do move 0 to R0. And load the value, 8 hex. So move R10, 8E. Something wrong, what's wrong? Then move R12, F7. Then you want to obtain the lower byte, lower 4 bit. So lower 4 bit, what you can do is that you can move R1 to 0F. So that's for masking. Then you can end this. Or you can also end it with an immediate value. Also can. Both of them also can. So 8E, you end it with 0F, you get 0E. F7, you end it with 0F, you got 07. So then you XOR, then you store it in R2, R12. So you XOR 0E and 07, you change it to binary. When you XOR, you get 1001, which have a value of 9. All right, you XOR it and you move it into the memory location R2, R specified by R3, which is 1000. Okay, so then you can store it. Okay, so let's do it on the simulator. Reset, delete, paste. Okay, 2 step forward, 1, 8E. So you can see 8E is here. Okay, this R10, R12, F7, then R1, 0F. Then when you end it, it becomes 0E. When you end it, it becomes 07. Then when you XOR it and install the result in R2, it becomes 9. Then move R3 1000. Then you store it. You see inside the memory, you can see the value 9 here. Okay? Clear? Clear? Okay. Close. Okay. Any questions so far? So far, so good? Okay. Question number 4, we can actually skip. Okay. This is the code. I don't think this question is very well prepared. So what it's saying is that B is 77, A is 81. Then you add it together. Okay, you add it together. And the result, you store it in memory location 7500. Okay? All right? Okay, so this one you can just retype everything as is it, then submit. All right, question is not very properly defined, the question. Okay. All right, question number 5. It said that the scenario, okay, so you have address, this address contain 40, this address 2040 contains 050. Then these are the value of the register, R1, R2, R3, R4. These are the value. Okay, so this is the scenario, and there's a 5 sub question there that is unrelated to each other. So given this scenario, you want to find out what's the value of R0. Okay, all right, so we're going to set up the scenario first. So this is the scenario. We're going to set it up. Okay, so you have scenario 1. Scenario 1 is that you move 20 to R0, so R0 become 20 lah. Okay, so it's pretty straightforward. Okay, all right. Then this one you add R0, R1 and R3, store it in R0. R1 is 40, R3 is 20. You can see R1 is 40, R3 is 20. So you get 60. Don't believe, you can see here. Okay, so okay, 60 here. Okay, reset. So you're going to do scenario 2, scenario. Okay, what is scenario 3? Scenario 3, you move R2 to R0. So R2 will become 1000. R0 will become 1000 because R2 is 1000. Never mind, you just execute it. Okay, forward. You can see R0 become 1000. Reset. Okay. Okay. So then you have this one. Load R0 to a memory location pointed by R2 with an offset of 40 bytes. So R2 is 1000. The offset of 40 hex also will be 40. So you want to load the value in the memory location 1040 to R0. Okay. So we have this one. So we run Step forward. R0 is 20 now. Okay. Okay. So you can see on the memory location. Or close. Memory location. Let's put. Okay. So you can see 1040. The value is 40 hex. Okay. 40 hex. So come here. Step forward. Okay, you can see R0 is 40. Before that, R0 is 20. Now R0 is 40. Okay? Alright. So the meaning of this instruction is that you load the the value in the memory location specified by here, which is 1040. Okay? And then you load it into R0. Okay. Then here what happened? You store R0 in the memory pointed by R2. Okay. Here we are. So this one we reset. So scenario 4. Okay, so we'll step forward. Okay, so we haven't run this instruction yet. R2 is 2000. R2 is 1000, eh? Then R0 is what? R2 is 1000. R0 is 20. Then the memory location 1000. See, 1000 is all 0. So let's do a step forward. So you can see 20. So you store it in memory location 1000, 20, the value of R0. Okay. So the last scenario is load this one, R4 offset by R1. Okay. We're going to run step. Okay. So R4 is what? R4 is 2000. R1 is what? 40. So the memory location 2040 is 50 lah. Okay? 50. R0 is 20. So you can see. So it becomes 50 here, R0. Backward, forward, backward, forward, backward. Okay? Like that. Okay? So this means that you're going to load a value in the load R0 with the memory location 2040. All right, 2000 is R4, 40 is R1. Okay. All right. The next instruction, specify the status register. Okay, so let's put here here. Okay. Reset. Okay. So you can see here. Oh, this one no memory, so don't have to worry. EOR XOR, all right, R0. So you can see here. Okay. Reset. Okay. Syntax error. Okay. So you can see syntax error. Okay. Now no syntax error. Okay. So XOR. So you can see the 0 flag is set. Because if you XOR anything with by itself, you get 0. So the value is 0. Then you subtract. Okay. Move. You can see nothing changes with the flags. Then when you add S, all right? So it's no longer 0, okay? The value is no longer 0 because R1 is, you add R1 by 1, so it become 100, okay? FF plus 1, it become 100. So the 0 flag is reset, okay? All right, but if you remove the S. You remove your S, all right? Then the flag is not set. You can see all the while the flags is not set. Okay, clear? So if you are smart enough, right? If you remove your S in the code, then you can see the flag is not set. Okay, this is pretty straightforward lah. Right. Then list the 4 basic operation of a computer. Is the input, processing, storage, and output. Okay, so these are the 4 basic unit. Then what are the basic instruction cycle? So you can see this is the basic instruction cycle. You have instruction address calculation, then you fetch, then instruction decoding, then you have the operand. You calculate, you fetch the operand, maybe it's located in the memory, then you do the data operation. Then you have operand address. This is the output. You need to store. Sometimes the output is stored in the memory, so you have indirection. After you're done with all that, then you check whether there's interrupt or not. If there's interrupt, execute it. If no, then you return back to here. Okay, clear? So is sweet. Okay, short and sweet. Anything? Just rewrite what I put in MMLS lah. If not, then other students for other tutorial group, they complain and all that. Okay, just write and put it in now. Okay. 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 Anything else? No, no. Then happy Taibusam.
Let me wait. Let me see first.
Okay. I can wait forever. Okay, take your sweet time. We got 2 hours.
I want to know about question 6.
Question 6,
Yes.
Okay. What you want to know?
Hang on. Let me see.
Okay, I run the simulator again.
Specify the flex.
Okay. Okay. First you XOR, correct? When you XOR anything with the same thing, you get 0, correct?
Yes.
Like this, notepad. Then you have 1, 0, 0, you get 0. 1. XOR 0, 0, you get 0. 1, 0, you get 1. 0, 1, you get 1. 1, 1, you get 0. There's XOR there. It's XOR. Okay? So if you A XOR A, then you got 0 because A is equal to A.
Yes.
A is equal to A. So if it's 0, it's 0. Then you have to see the instruction. Right? Whether it's, we have the S here, okay? You can see the S. S. So if there's the S, if there's the S, that means that the flags are affected. Right? So the 0 flag will be set lah. The first instruction, the 0 flag will be set. Then subsequent instruction, no S in it, so the flags will not be set. And then here, you have add R1 with 1, okay? R1 is what? You add 1, okay? So when you add it, okay, the result of this operation adds R1 with a value of 1. Okay, with a value of 1. So what is R1 is F, right? Plus 1 will become 100. This operation, what's the value of the flags? Value of the flag, the carry, is it negative? No. Is it 0? No. Is it carry? No. Is it overflow? No. So the flags value will be, okay, so the operation. Okay, you can see here. Reset. Let's say, reset, run again. Let's say if you don't have this one, you don't have this one, both of them don't have, then you run, the flags is not affected because there's no S in the instruction. Let's say you have this one. Okay, step forward. Oh, flag is affected. Then after that, you can see the flags remain unchanged. Okay? Okay?
So they're not changing anything.
If okay, it depends on the instruction. Instruction don't have S and flags okay? If got S, then the flag may or
Uh, may affect it.
may not touch, right? So S how to touch, right?
Mm-hmm.
All right. No S how to touch the flag. No flag. Okay. If there's S, the instruction, the flags may or may not be touched, or you can say set. Okay. Depends on. Okay. Okay. Clear. Clear.
I think so.
What is the use of the flags? The flag is used for you to enable you to branch, to jump. Okay.
The what?
That's the
The branch and to jump.
yeah. So let's say you have a code. If A equals to 1, or if A equals to 0, then celebrate. Okay, celebrate. Else, study. Okay, so you want to do it in the code, so you have to say compare, how is it? Compare, let's say R0. I need to refer to the instruction set. I'm not that familiar with the Intel. With the proof arithmetic logic test. Okay, so you can test. So let's say you move R0 memory location, memory of A. Okay, then you load R1. Okay. Then you have to test whether R1 is equals to 0 or not. Okay? So since it's involved flex, okay, or you can do this one. You can do what you can do. You can add. Okay? So then you can do branch 0. Okay, branch is the 0. Branch link 0. So we go to label 1. Then label 1. There you go. Branch always. Branch always. Yeah, branch always is what? Always. Branch equal 0. Okay, branch equal. Branch equal. Branch always n. So here is. Over here is. Then it has celebrate typosum. Okay. Then the n go here, you do nothing. Okay. So you add R1 with R1. If R1 equals to 0, equals 0, branch equal. So over here, what do you say? Branch equal 0 lah. Okay. All right. If the Z is equals to branch equal right, to label 1 or okay. All right. So this is a sample code. Okay, for you. So you use the flex for you to test the condition. Okay. Any other question? Any other question? In your report, you just submit question 4 to question 8. Okay. Discount. Typosum discount. This Saturday, I believe. The sample is already in the MMLS. This Saturday, midnight. 4 to 8 only. Very short, shorter than the circuit one. The one is less than one question. Like the digital system, you have circuit diagram, logic diagram, Karnoff map, truth table. All right. Actually, I give everybody Sunday 0 hour. I cannot extend afterward. You know, MMU student is okay. I stop the recording.